Hello, so in today's video, we're just going to make clear or remind ourselves that when you have a circle, the tangent at a particular point on a circle and the radius touching that particular point are perpendicular. So that's the key fact. The tangents and radii form 90-degree angles. They are perpendicular. So let's look at a diagram to help us out with them. So let's say we've got a circle like this. On the xy axis, a center at A, B, those coordinates in the middle there. And let's say you've got a point capital A up there. Well, let's draw a radius in between the center and A. So that's our radius there. If you draw in a tangent line like this blue tangent line, maybe something more like this. So blue tangent line in like that. That's our tangent line. It just by doing the eye test, it looks quite obvious that this is a 90-degree angle there, and in fact it is. So all you need to know is that it is fact that tangents and radii form 90-degree angles when they meet at a certain point on a circle. So yeah, these are R. Actually, no, I'd write it like this. So radius is perpendicular to tangent on a particular point where they meet. So that's the key thing that we want to bear in mind when we're dealing with coordinate geometry with circles. Okay, so we've got an example here where we're going to use that fact. So let's consider a circle, and it's got a center of -1, -3, and a radius of r. Okay, so we don't know the radius yet. So given that the point -13, 2 actually lies on this circle, part one, we've got to find the equation of the circle. And part two, we've got to find the equation of the tangent to the circle at -13 and 2. Okay, so let's think about this question then. So let's start with part one. It's always a good idea to draw like a rough sketch of what we have, just so we're aware of what we've got. So we've got a circle with a center at -1, -3. So -1 on the x-axis, -3 down here, perhaps. So we've got a middle somewhere there. And then we're going to pass through the point -13 and 2. Okay, so -13 might be somewhere like all the way back here, and 2 upwards by 2 there. So it's going to pass through that point there. So from there to, I'll do like a dotted red line to make it clear that it's not part of the circle. But essentially, this is going to be our radius, like here. And what you've got is you've got a circle which kind of does, I mean, it's going to go off the page, but I mean, a circle roughly like that. And that would be your radius there. So from there to, I'm actually just going to draw in a straight red line. So from there to there, that's our radius. I'm going to rub out these dots there as well, just to help out. So that's our radius, radius of r, and it goes from this -1, -13 point to this -2, and sorry, this -1, -3 point to this -13, 2 point up there. Okay, so how are we going to find the radius? Well, you can probably imagine we're going to need to use Pythagoras, because look, we've got a kind of like a hypotenuse here. We've got a right angled triangle we can make if we do this. That becomes right angled. So we want to work out the gap in our x coordinates, the gap in our y coordinates, and then square both numbers, add them together, square root them using Pythagoras. So for part I, to actually find the equation of the circle, obviously we need to find the radius. So let's just make a point of this. So the equation, equation of circle is in the form x minus a squared plus y minus b squared equals r squared. Now we know the center. The center is -1, -3. So actually, for our equation, so our equation is going to be x minus -1. So the a value in this case would be -1. It's going to be -1. So x plus 1 squared plus y plus 3 all squared equals this radius squared. Okay, so again, the key point is that yeah, so this is the equation of a circle with a center at a b. So if you have a center of -1, -3, then your a value is -1. So x minus -1 is x plus 1, and y minus -3 is y plus 3. So that's the key point to realize. So our equation is going to be like this, but we need to work out the radius because we don't know the radius. So that's what I was saying before. We're going to need to use Pythagoras. So we want to work out this this distance, this base distance of our triangle, and this height distance of our triangle, and then use Pythagoras. So what would the base difference or distance be? So the x coordinate there is -1. So this is -1 there. The x coordinate there is -13. So the gap between them is 12, isn't it? you've got a gap of 12. So yeah, -1 minus 13, that's 12. So you've got a gap of 12. What about the gap in our y coordinates and our y direction? So we go from -3 up to 2. That's a gap of 5. So you've got a gap of 5 up there. Let me just get rid of these squiggly blue lines. Let's just do arrows instead to make it look a bit neater. So yeah, you've got a gap there of 12. You've got a gap there of 5. You can now use Pythagoras. So our radius squared, so using a squared plus b squared equals c squared. This is our hypotenuse. A red line, our radius is always our hypotenuse. So we've got 12 squared plus 5 squared equals r squared. Now 12 squared is, well, that's 144. 5 squared, well, that's 25. So that's going to be 169, which is r squared. So the radius will be the square root of that, which is 13. So we know our radius is actually 13, but we actually don't need that because the equation of a circle has r squared there, not r. So our equation, so therefore, x plus 1 all squared plus y plus 3 all squared equals 169. That is the equation of our circle. So that's part 1 done. So we've got our equation there. Now, how about part 2? So we've done that. Find the equation of the tangent to the circle at -13 and 12. Okay, so now we've got to find the equation of the tangent. I'm actually going to do a new diagram. I'm going to go to a new page. So part 2, sorry, let me write this again. Part 2, find equation of tangent. Okay, so how would we do this then? So again, let's draw like a rough sketch. So we've got our -1, -3 center. You've got -13 and 2 up there. So again, something like this perhaps. I mean, that's a really awful diagram, but you get the point. Center out there, and we're going to go through this point here, this -13 and 2 point, and we want a tangent to this point. So a tangent, remember, we've got our radius going from there to there. We want a tangent which is perpendicular, and tangents go like this. So this is going to be our tangent there, this red tangent line, and we want to find the equation of that line. Okay, so now this is where we need to use our fact from back here. Tangents and radii are perpendicular. So a radius and a tangent is perpendicular. Now we know from our knowledge on coordinate geometry that if if two lines are perpendicular, then their gradients are the negative reciprocals of each other. So let's just say that this gradient of the radius here, let's just say the gradient here, I'll do this in a different color. So let's say the gradient of the radius, so grad of I'll just call r for radius. Let's just say that's m. Then the gradient of our tangent, so grad of tan, well, that's going to be equal to -1/m. So we can use our fact that perpendicular lines have negative reciprocal gradients, and we can use that to get the gradient of this tangent line, and that's going to be when we use the y equals mx+c equation formula for the tangent, straight line equation of the tangent. We know that our gradient is going to be the negative reciprocal of the radius gradient. So step 1 then, so step 1 is to actually find find the gradient of the radius. So find gradient of line. So the gradient of the line from the coordinates -1, -3 to this -13 and 2 point up there. Sorry, this should be a 2. So -13 and 2. So we want to find the gradient between that. So again, it's using our gradient formula. So gradient is change in y divided by change in x. So changing your y coordinates divided by your change in your x coordinates. So y2 minus y1 divided by x2 minus x1. So your second y coordinate there is the number 2. Take away your first one, so take away -3 there. So that's that. So take away -3. And then your change in x, again, you've got to be consistent. If you pick the first y coordinate, sorry, the second y coordinate first, you must pick the second x coordinate next on your denominator. So we've got to pick the -13, our second x coordinate, and then take away our first our first x coordinate, so take away -1. So then if we solve this, so we get 2 plus 3, which is 5, and then -13 plus 1, -12. So this is -5/12. Okay, so the gradient of this line here is equal to 5/12. Okay, so we got -5/12. So how about the gradient of the tangent? So again, this is our negative reciprocal. So flip the fraction upside down, put a minus sign in front of it. So let me just make that 5 clearer. Yeah, flip the fraction upside down, negate the symbol. So that means the gradient, so gradient of tangent, that must be equal to positive 12/5. So gradient of tangent, negative reciprocal, negative 12/5. So positive 12/5 as our gradient up there. So let's just fit this in. So this is 12/5. Okay, great. So let's just make the writing a little bit smaller so we can fit our work on the same page. And let me just move this up there. Excellent. Yeah. So now we can now write down the equation of the tangent. So the equation of the tangent, well, that's going to be y equals 12. So mx plus c, y equals mx plus c. Remember, this is a straight line, so it's always going to be y equals mx plus c for a straight line. So y equals the gradient 12/5 times by x plus a c value or y-intercept that we don't know. So now our next step is to so yeah, I mean, step 1 there was to find the gradient of the radius. Step 2, I'll just make this clear. Step 2 is to actually get the negative reciprocal, and then step 3 now is to find the y-intercept. So find the c value. So what would our y-intercept be? Well, we just want to plug in the coordinates. So on this straight line, the point -13 lies on that straight line. So we just want to substitute x equals -13 and y equals 2 into this straight line equation there, because the line literally passes through that point there. So we're going to sub in, so sub in x, y equal to -13 and 2 into this straight line equation there. And if we do that, we get, so 2 equals 12/5 times -13 plus c. So that would be, again, I'm just going to try and keep this all on the same page. So we're going to get, so 2 is equal to 12 times -13. So that would be minus 156, I think, divided by 5. I'm just going to check that on my calculator just to make sure I've done that right. 12 times 13, yeah, minus 156/5 plus c. So add the 156/5 to both sides. We get c is equal to so 2, which is the same as 10/2, sorry, 10/5, and then plus 156/5, which is 166/5. Brilliant. So therefore, our equation, so equation of tangent, sorry, write this again, equation of tangent. So that's going to be y equals 12/5 x, and then plus 166/5, and that would be our final answer down here, this equation there. We could also rewrite it like this. I mean, I'll just do this on a box over here. So if the question asks you to write it in a form ax plus by plus c, you would do this instead. So 12/5x plus 166/5. You can times both sides by 5, so you get 5y equals 12x plus 166. And then if you take away the 5y from both sides, you get 12x, take away 5y plus 166 equals 0. So if the question asked for the form ax plus by plus c equals 0, then this would be your result up here, this answer there, which is exactly the same again as this equation down here. So we've done it. We found the equation of the tangent. We've got the equation of the line, which was sorry, of the circle. Sorry, so this one here. That's our equation of our circle, and this is the equation of our tangent at this particular point up there. So yeah, so the whole idea of this video is to look at this fact here, that tangents and radius, a tangent and a radius are perpendicular when they meet at a particular point on a circle. again, I'll make a note of this here. Radius is perpendicular to tangent at a point on a circle. So at a particular point on a circle, this fact is always true. And you can use Pythagoras as well. Again, I'll make a note of this. You can use Pythagoras to work out size of the radius. So use capital letters, use Pythagoras. Use Pythagoras to find the size of radius. Because you can just use the gap there squared plus the gap there squared, square root it, you'll get your radius. Or if you just want the r squared in your equation, you actually don't need to square root it, because a squared plus b squared will give you the r squared. So that's this video for today finished.